Hey everyone, so this is the part 2 of Destructor, and we are going to continue with the Destructor topic again. So in the last video, we saw the properties of the Destructor, how Destructors are called in different scenarios. We also saw few tricky scenarios related to Destructors and how to deal with them. Now, the one thing that we missed to discuss in the last part was related to the arrays. How do we delete the objects inside an array? So let us take an example, arrays. Now what I'll do is I'll create a pointer of type A star P2. And this time, instead of creating a single object, I'll create an array of object. So let us keep the sizes 2. Now we have an array of size 2 and both the elements are of type A. Now in this case, if you want to free the array or release the resource, then you have to call delete square parenthesis, then the P2 pointer. So in this way, it is going to delete the array. So now if I'll try to compile this, it compiles successfully. And if I'll try to execute this, you won't be able to distinguish much. Let us just comment them out, all of them. Now let us try to compile it again. And this time we can see the delete is called twice or the destructor is called twice because we have called delete onto an array. So in this way, you call the delete on an array. Now there is one more way how you can allocate the memory is using the malloc. So again, we are going to have an A star or a pointer, and this time we are going to keep it in P3, and we are going to use malloc, and inside this, I'll just pass size of A. Now since it returns me a void pointer, so I have to typecast it A star. Now we have allocated a memory and we have saved the address in the P3. If I'll try to call free now, free on P3, and we'll just comment out the above ones, and let us try to execute this and see what happens. So you can see I compiled the code, it compiled successfully, it executed successfully, but still it does not call the destructor. Why? Because the free does not call the destructor. It only releases the memory. It does not call the destructor. And in the same way, malloc also allocates the memory. It does not actually calls the constructor. So these are certain differences I wanted to show you because it is related to destructor. But for a complete deep dive in new, delete, and malloc and free, I have a complete separate video. You can watch the video. I'll provide the link in the comment section. Now let us move on to the inheritance part, and we will see how the destructor behaves when we are dealing in the inheritance. So I'll create another file, inherit.cpp. So this time, let us write down some boilerplate code. And now I'm going to create two classes. One is the base class and the second is the derived class. So class base, class derived, and it is going to publicly derive the base class. Now in both these classes, I'm going to keep the constructor and the destructor. So let us say we have a base constructor, and inside this, I'll just see out base constructor. And then we have the base destructor. And just to save the time, we are going to copy both of them, paste it inside my derived class, and we will just change the names. So now we have the base class constructor destructor and the derived class constructor destructor. And I'll keep both of them in public. Right. Now in my int main, the first thing that I'll show you is what happens when I create a derived class object, derived t. If I create a base class object, it is very straightforward that it is going to call the base class constructor and when it goes out, it calls the base class destructor. But we want to see what happens in inheritance. So we are going to create a derived class object. Now, if I try to compile this, G++ inherit dot cpp inherit, and it compiles successfully. Let us try to run this. And you can see first the base class constructor was called, then the derived class constructor was called. But when we went on to the destructor, when it went out of the scope, it called the derived class destructor first, then it called the base class destructor. So you can see the sequence very clearly here. So while calling the constructor, the base class comes first, then the derived class. Whereas while calling the destructor, the derived class comes first, then the base class. And the same behavior is applicable if I'm just going to create it dynamically. So instead of doing this, if I'll say derived pointer p equals to new derived class object, then in this case, you will see that it is going to behave the same, that first the base class constructor will be called, then the derived class constructor will be called. But to call the destructor, I have to delete the pointer p. Now, if I try to compile this, and if I'll just execute this, the output remains the same. But what happens when we try to deal with the runtime polymorphism? So instead of saving the derived class object inside the derived class pointer, I'll just save it inside a base class pointer. Now I'm trying to delete the pointer p. So this time, if you would see the output, it is just going to call the base class destructor. It called the base class constructor, then the derived class constructor, and after that, it just called the base class destructor. It did not call the derived class destructor. That is because the pointer is of base type. Now, in this case, the most important thing is since you created a derived class object, so if you were having some dynamically allocated memory inside your derived class, then it would go under the memory leak because you are calling the destructor for the base class, not the derived class. So any dynamically allocated memory which is held by the derived class will not be released. So it will go under memory leak. So to avoid that, what we do is we add a virtual keyword over here. So now our base class destructor is going to become virtual. And since we are inheriting from the derived class, so the same base class destructor will be virtual inside the derived class as well. Now, if I'll execute this again, now this time you can see first the derived class destructor is called, then the base class destructor. So this time it will work absolutely fine and no memory leak will happen. So while coding, you should remember all these practices so that you can write a clean code without causing an error. So I hope you like this video. Do like and subscribe. Thank you.